Hi, everybody. This is Mr. Falli, and welcome to Podcast 3.1, the Periodic Table. We're going to explain how the elements are organized in today's periodic table and understand Mendeleev's role in its creation, state and explain the periodic law, identify and name specific regions of the periodic tables, etc., etc., etc. So let's hop right to it. Oh, come on now. It's the 16th of the month, so guess what? Oprah Magazine is coming! Woot woot! So, it's the 16th of February. Look, there's Oprah. I got my Oprah magazine. 16th of March. Look, there's Oprah. Oh, look, she's skinny. Look, it's the 16th of April. Look, there's Oprah. Oh, she looks different. Oh, there's the 16th of May. Oh, look, she's different. So, periodic means repeating. So, periodicals, right? That's what magazines are. Periodic means repeating. Periodic means repeating. Periodic means repeating. Periodic means repeating. Hey, look, this is a periodical. So, the periodic table means repeating. When atoms are arranged by atomic number, that's protons, trends will repeat. So for size, for example, for size you get big, small. Then you get to this row, it's big, small. And then you get down here, it's big, and small. And then the other one that we will get to, won't let me erase, is the charge. And the charge is based on the column. So plus 1, plus 2, plus 3, 0, minus 3, minus 2, minus 1, 0. Then if I'm down here, it's still going to be plus 1, plus 2, plus 3, 0, minus 3, minus 2, minus 1, 0. It repeats, it repeats, it repeats, it repeats. You do need to know the charges on the periodic table, and you do need to know this is the big inside, and this is the itty bitty little side. Columns are the same thing as families, same thing as groups. Okay, so this is a column. Okay, so this can be called column 1A or just column 1. Both of those work. Okay, this would be column 2. This would be column 3, 4, blah, 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 all the way up to 18. I'm sure you can count. Now, the A columns are Roman numeral 2A. The A columns are tall 3A, blah, 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 all the way up to 8A. Okay? A period is a row. So, for example, calcium right here is in column 2, and it is in period 1, 2, 3, 4, period 4. Periods are rows. Okay, so if I were to look at fluorine, fluorine is in, I'll do it over here, column 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, or 7A, period 2. Series are special, like The Simpsons. So these are the inner transition series. Okay, so if you see these guys right here, they're special. So they're pulled out on their own. So you just need to know that they're really odd because notice how it goes 55, 56, 57. Number 58 goes down here, 87, 88, 89. Number 90 goes down here, and you pull that out. So those series are special, and they're not even included in the columns. Okay. History. Dmitri Mendeleev saw trends when atoms were arranged by atomic mass. Oops. Now, what was wrong with it? He was wrong. You were wrong, my friend. We're arranged by atomic number is the correct thing. Okay. He predicted elements and their properties before they were discovered. So basically, he had a little periodic table, looked a little something like this, and he said, wait a minute, there's a hole right here. And he said, all right, all you other chemists, you go find one. It was a very bold, bold, bold thing to do. And he was right. Okay. Who says science doesn't change? Dumb people say science doesn't change. Science changes. Okay. So Mendeleev was smart. He had a good idea. He had a smart wrong answer, and then we made it a better wrong answer. You'd know the name Mendeleev. He predicted elements and their properties before they were discovered. Yay, Mendeleev. Charge is periodic, and this is, if you wrote it down before, you don't need to write it down again. Plus 1, plus 2, plus 3, 0, minus 3, minus 2, minus 1, 0. So what's the charge on gallium? Gallium's in the plus 3 column. It is gallium plus 3. What's the charge on cesium? Cesium's in the plus 1 column. Cesium plus 1. These guys, don't worry about them. Whee! Regions of the periodic table. Your periodic table, and I hope you keep drawing more and more and more periodic tables, has these guys in it. Okay? Has that line right there. Metals are on the left. Metals are on the left. None of the stair step of stairs. Non-metals are on the right of the stairs. And metalloids are on the stairs, except for aluminum. So your metalloids are boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and astatine. They're your metalloids. These guys over here are the nonmetals. These guys over here are the metals, with one exception. Hydrogen is a nonmetal. These guys down here are metals. Okay. Properties of metals are luster. Luster means shiny. Shiny means that you are reflective. The word, this is not shiny, this is shinny. This means full of shins. If you say something is shinny, that's wrong. Metals conduct electricity. Yay, metals, wires, yay, my stuff works. Metals tend to be solids. Metals tend to be malleable, which means they're bendable. And acid reactors, which means they bubble in acid. Nonmetals do the opposite. Okay, I should write that down. You need to write that down. Non-metals opposite of each of these, of all of those. Lanthanide actinide series. Here's the lanthanide series. Lanthanide. Boom. You just need to know where they are. There's lanthanide. Actinide. Actinide. Bam. Transition metals. See that crossbar right there? These are the transition metals. And then the inner transition metals are both of these inner trans. So I think of this as lanthanide is the city I'm in, inner transition metals the state that I'm in. Ohana means family. Lilo and Stitch say family means nobody is left behind or forgotten. Chemists say families are columns and have similar properties. Hydrogen is an orphan like Stitch. So if I look at this, lithium is more similar to sodium and potassium because they're in the same family, Ohana, than the other ones. Okay, you will need to know these groups. Alkali metals. Alkaline earth metals. Oh, I need to change this. I made a mistake. I was taught this is called the aluminum group, but it's called the boron group. Carbon group. Nitrogen group. Oxygen group. Why am I making that weird noise? I don't know. Halogens. Oh, bet you thought it was the fluorine group. Those are the halogens. Noble gases are right here. So you need to know those columns. So if I said, what family is tin in? You would say it's in the carbon family. That's it. Oh, I better hurry. The bell just rang. Synthetic elements are the ones mostly above uranium. So notice uranium has 92 protons, and that's all you need to know. So more, these are the examples of all of them. More than 92 protons equals synthetic, meaning man-made. Oh, goodness, I hope I'm almost done. Radioactive elements are 83 and up. So radioactive means that it shoots out radiation, alpha, beta, or gamma rays. So you just need to know that. If it's number 83, and number 83 is bismuth. And for some reason, what helps me is lead is stable. Lead is stable. So it's the last stable one. It's a big element that goes with that. So if I'm in the same family, we'll have similar sizes. Dink. We'll have similar reactivity. Dink. We'll have identical charges. Dink. You learn I wet my pants in second grade waving my hand in the air to ask to go to the bathroom. Or was that Morgan? Ha, 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 ha. I should have changed that to somebody else, but I didn't. That's the family joke there. I'll be different from my neighbors on my left and my right. So if I'm in the same family, this is the same. This is different. Okay? So are these traits periodic? Size? Yes. Charge? Yes. Reactivity? Yes. Periodicity is due to similar electron arrangements. Hey, looky right there. I'd write that down in bold. Bold. With arrows. Arrows. And then we get to keep going. Review. There's too much writing in this podcast, but I got it in about 11 minutes. Families. It's the same thing as groups. Same thing as columns. Same thing as up, downs. Periods are rows where traits change, but repeat. Yes, you need to memorize the groupings. Periodic means repeating. Periodic means repeating. Periodic means repeating. What is periodic law? Trends repeat if arranged by atomic number. Oh, I forgot to play more Lilo and Stitch for you. So for that, I will say toodles and aloha.